Hello students, good afternoon. Welcome to the second part of the chapter D and F block element. In this part, we will discuss about the general properties of transition elements. Okay, so the first property is atomic radii. The atomic radii of transition element lie in between those of S and P block elements, and they are listed in the table. Okay, so there is a first transition series, second transition series, and third transition series. Scandium to zinc, and yttrium to hafnium, yttrium to cadmium, and lanthanum to mercury. Okay, so if you will see on going from left to right in a period or in a series, the atomic radii will decrease gradually in all the series. Okay, because force of attraction between the outermost electron and nucleus will increase. Okay, scandium has 164 picometer and zinc has 137. So atomic radius decreases along the series. So the atomic radii of transition element exhibit the following trends. In general, the atomic radii of transition elements belonging to a particular series decreases with increase in atomic number. The decrease become small after midway. Explanation. What is the explanation? In the beginning, the decrease in the atomic radii with increase in the atomic number is due to increase in the nuclear charge. As I have discussed before that the atomic radii decreases because of force of attraction between nucleus and outermost cell of valence shell increases. Okay, as the atomic number increases, the added electrons enter into n minus 1 d subshell and shield the outermost electron, and the shielding effect increases with increase in the number of d electrons, that is with increase in atomic number. Thus the effect of the increased nuclear charge due to increase in the atomic number counterbalanced by the increased shielding effect of n minus 1 d electrons, and that's why the atomic radii remains almost constant after midway in each series. Okay, near the end of each series there is a slight increase in the atomic number. So toward the end of a series, the electrons repulsion between added electrons in the similar orbital predominant over the alternative attractive force due to the increase in nuclear charge. Why near the end of each series there is a slight increase in atomic number? Because on increasing electrons within the cell there is a repulsion between electrons will take place, due to which this electron repels the cell outer side, and hence at the end of each series there will be slightly increase of atomic radii. Okay, so that this is the reason. Now, ionic radii. Ionic radii of transition element follow the same trend that exhibit various oxidation state. The radii of ions are different in different oxidation state. In general, the ionic radii decreases with increase in the oxidation state. Okay, so as oxidation state increases, then atomic radii will also be increase. Okay, you can see here the decrease gradual decrease in ionic radii in going from titanium 2 plus to copper 2 plus ion is due to an increase in the effective nuclear charge. The ionic radii of the transition elements are smaller than those of the repetitive elements of the same period. Okay, so now metallic properties of lattice structure. So almost all transition elements exhibit a typical metallic property such as a metallic cluster, malleability, ductility, high tensile strength, high thermal and electrical conductivity, except zinc, cadmium, mercury and manganese, because they have one or more typical metallic structure at normal temperature, which are listed in table. So you can see here metallic character. Scandium contains lattice structure of SCP and BCC, titanium SCP, BCC, vanadium only body centered cubic, hexagonal closed packing and body surface centered cubic, like that. So in this form they are exist. Metals are exist in this crystal lattice form. Okay. Now come to the melting and boiling points. So as we know that all the elements of transition metals are metals, so due to which the melting and boiling points of transition elements will be melting and boiling points. The melting and boiling points of transition metals are very high as compared to those of representative elements, means S and P block elements. The melting point first decreases, attains a maximum value, and then steadily decreases as the atomic number increases. Okay, this is the evident from the data shown in 8.3. So the high melting boiling points of transition elements are due to their close packing structures. In these structures, the transition metal atoms are held together by strong metallic bond, which have considerable covalent character, as explained earlier. Due to covalent character, they have high melting and boiling points. Now, enthalpy of atomization. Transition elements in general exhibit higher enthalpy of atomization. The elements of the second transition series, means 4D series, and third transition series, means 5D series, have greater enthalpies of atomization as compared to the elements of first transition series. Okay, this is why they have much more frequent metal-metal bonding in their compounds. The higher value of enthalpies of atomization of transition band may be attributed to the presence of a large number of unpaired electrons in the atom. So as well as the unpaired electron will increases in an atom, their atomization energy will be increases. Okay. Now okay, atomization energy will be increasing. Now ionization enthalpy or ionization energy. So what is the definition of ionization energy? The removal of one electron from their valence shell is known as the ionization energy. So the ionization enthalpy oblique energies uh, of transition elements or D block elements lies between those of S and P block elements, and they are higher than those of S block elements and lower than those of P block elements. The first, second and third ionization enthalpy of the elements belonging to the first transition series are listed in 8.5 table. Scandium first ionization enthalpy 631. So you can see here on increasing in a series the ionization enthalpy of the elements increases because removal of electron become difficult. And why this difficulty will come? Because as well as the electron will increases in their valence shell, the force of attraction between nucleus and valence shell increases, and hence to remove one electron from their valence shell we have to apply more energy, and due to which the ionization enthalpy increases in a series. Now electrode potential. So the standard electrode potential of some half cells involving the transition metals of the first transition series are listed in the 8.6. The values of, so following conclusion can be drawn from the data listed below. You can see here for different type of ions there are electrode potential value are given which are in negative. What does it mean? So following conclusion can be drawn from the data listed in table 8.6. The standard electrode potential of transition metals do not exhibit any regular trend, and this is due to the irregular variation in the transition variation in the ionization and sublimation of energies across a particular transition series. Standard Okay, except copper, all other elements of first transition series possesses negative value of standard reduction potential. This is why they act as a reducing agent. Means the element which possesses negative electrode potential value will act as a reducing agent, and which contains positive will act as a oxidizing agent. So copper is unable to liberate hydrogen from acids. This is why of its positive value, so it will act as an oxidizing agent. Okay, thank you, have a nice day.